Welcome to the deep dive. We know you want to get the key info without wading through tons of text, so today we're looking at something called defect density.
Yeah, it's a term you hear a lot in software development.
Right, and it basically tells you how many problems, defects show up in software compared to how big it is.
Yeah, exactly. And the sources we've checked out, they explain what it is, how you figure it out, and maybe most importantly, why it actually matters.
So our mission for this deep dive is pretty clear. Get a solid handle on defect density and what it means in practice.
Let's do it. So the core idea.
Okay, so at its simplest, defect density is just the number of confirmed defects, the actual bugs found, divided by the size of the software.
And that size is often measured in lines of code, right, Leslie?
Usually, yeah. Lines of code are sometimes KLOC, that's thousands of lines of code.
Yeah, sure.
So the formula is pretty basic. Defect density, total defect count size of release.
Okay, maybe an example would help make that concrete.
Good idea. So imagine you have, say, 3 different software modules. Module A has 10 bugs, and it's 1,000 lines long. Module B, maybe 20 bugs and 1,500 lines. And Module C, another 10 bugs, but it's smaller, like 500 lines.
All right, so if you add that up,
yeah,
that's 10 plus 20 plus 10, 40 bugs total.
Exactly. And the code size, 1,000 plus 1,500 plus 500. That's 3,000 lines altogether.
Okay, 40 bugs, 3,000 lines. So the density is 40 divided by 3,000.
Which comes out to, let me see, about 0.0133 defects per line.
Or if we use that KLOC measure,
Good.
multiplied by 1,000, it's like 13.3 defects per 1,000 lines of code.
Yeah, so we have this number, 13.3 defects KLOC. But what does that actually mean? Is that good? Average?
That's really the million-dollar question, isn't it? What's a good density?
Yeah.
Well, the sources suggest there isn't one single answer fits all, but there's a sort of general benchmark people throw around.
Which is?
Around 1 defect per 1,000 lines of code. So 1 defect KLOC, that's often seen as a sign of a pretty solid, good quality project.
1, wow, that sounds really low compared to our example of 13.
It does. But it highlights how complex software is. And crucially, that 1 is just a general guideline. It can vary a lot. Like software for a pacemaker, you'd want that density incredibly close to 0.
Makes sense. A simple game, maybe you could tolerate more.
Exactly. And other things influence that number too. It's not just about the final count.
Like what else affects the defect density score?
Well, code complexity is a big one. Really tangled, complex code. Probably going to have more bugs hiding in it.
Okay, it's intuitive.
Also, what you even count as a defect matters. Are minor visual things included, or only things that break functionality?
Ah, right. Definition matters.
Totally. And, the skills of the developers and the testers obviously play a huge role. Plus, the time frame, are you measuring defects found over a week or the entire project?
So it's a useful metric, but you need context.
Absolutely. You can't just compare raw numbers between totally different projects or teams without understanding that context.
Okay, so knowing all that, why do teams track it? What are the actual benefits?
Well, there are quite a few, actually. It helps measure how effective your testing is. If density drops after a testing phase, maybe your testing is working well.
Okay.
It also lets you compare different parts of the software. Remember our example. Maybe one module consistently has a higher density.
So it flags areas needing more attention.
Precisely. It helps pinpoint high-risk components, maybe areas where the code is too complex or testing was weaker. It might even show where developers need more training on certain things.
And I think the sources mentioned something about estimating future work.
Yeah, that's another key benefit. Looking at historical defect density helps teams estimate. They can sort of predict how much testing and bug fixing effort might be needed for new features.
Interesting, like forecasting potential problems.
In a way, yes. It can even give a very rough estimate of defects that might still be lurking in the code. All this helps make better decisions about, is this software really ready for release?
So it feeds into that go-no-go decision for shipping the product.
Definitely. You aim for a reasonably consistent and hopefully low defect density before you release it to users.
Okay, so wrapping this up, the main takeaway seems to be that defect density gives you a valuable kind of quality snapshot. It connects the raw number of bugs to the actual size of the thing being built.
Exactly. It quantifies quality in relation to effort or size. And just as a final thought, consider that benchmark we mentioned. 1 defect per 1,000 lines often being seen as good.
Yeah.
It really makes you think, doesn't it? Even with good quality, there's an expectation of some flaws in every 1,000 lines of code. It just underscores how incredibly complex software development is and that constant push for better quality we see everywhere. Something to maybe ponder next time your app glitches.